Good afternoon, Singapore. I'm Sab. I head our product and solutions marketing for Smart Analytics. And today we are going to talk about how Google Cloud is innovating with Smart Analytics and AI. It's going to be a power-packed 35 minutes. I'll be joined by my colleague Reza, and he's going to do a live demo to make things real. And then TK, Chief Investment Officer of Grasshopper, talking about how they are using Smart Analytics to make their business move forward. So without further ado, let's get started. So I go around the globe and talk about smart analytics. And every time I talk to a customer and a partner, they ask, what's new? Why Google Cloud is investing so deeply? What's fundamentally different? If you think about modern statistics, it goes back to 1749, Bayes' theorem, Laplace algorithms. So what has changed? The fundamental premise of data analytics is going through a transformation. We cannot think about applying analytics the same way you used to apply possibly 100 years back. And why this is the change? If you think about the digital era, which started back in 2002, almost 17 years back, for the first time, the total digital data storage capacity surpassed the total analog data storage capacity. And from then, every year on our planet, the amount of data that we are generating is growing with a compound annual growth rate of 60% plus every year. So what does this all mean to you as you are running your businesses and you're trying to be data-driven as companies? The traditional analytics systems will not be able to live up to this astronomical data growth. These were not designed to handle data at large scale. Data analytics has fundamentally become big data analytics. So this is from IDC. I'm sure many of you have gone through this, and you know that the amount of data that we're going to generate by 2025 is going to be 175 zettabytes. It's a lot of data. Let's keep it simple. What does this mean for you? As I was saying, if you think about the MPP systems of data warehousing, like a lot of traditional data warehouse vendors, they were building systems because the SMP-based data warehouse systems were not just good enough. You needed to have distributed computing capacity. But when you are exposed to this amount of data, the on-premise traditional architectures are not going to be sufficient. So what's the answer? Now, Google has been in the space for big data for more than a couple of decades. It's the only company that has 9 products with each having 1 billion+ users. So our engineers are managing big data problem every day. Google is a big data company. And with Google Cloud, we are bringing the best innovation on distributed data analytics and data processing and making it accessible to our customers so that you can build smart, intelligent, data-driven applications. So let's quickly go through what we are doing in terms of smart analytics stack. Smart analytics is not a piecemeal problem anymore. It's not just about BI. It's not about Hadoop and Spark-based data processing. You need to think about the data pipeline end-to-end when you are exposed to this large amount of data. We are working with customers who are ingesting data from offshore oil rigs to traditional CRM and ERP systems, ingesting data at massive scale, and we are going to give you some of those examples today. Processing that data in real time, storing that data in the data warehouse system, and then visualizing, analyzing that data using traditional dashboards, reports, or building machine learning models using our AI technology. What's important in this is all the services, starting from ingestion to processing to storing and analysis, are all integrated with each other so that you don't spend a lot of time stitching together the services. The APIs can talk to each other. You can have seamless handoff between data ingestion and data processing services. Cloud PubSub, Cloud Dataflow. Reza is going to talk about how you can build planet-scale streaming ingestion service using our technology. So number one, it's comprehensive. We are investing in a platform that lets you build analytics solution end-to-end, starting from ingestion, from on-premise or cloud-based systems to actually visualizing and building ML models. If you don't take anything out of my talk, this is the most important slide. And I talk to CIOs across the globe about the notion of serverless analytics. What does this mean? I started my career 15 years back as an analytics engineer. And you talk to anybody who is in the business of building analytics systems, 80% of the time is spent on system engineering related tasks, building indexes, doing disaster recovery, backup, multi-tenancy, capacity planning for peak hour times. What we are doing is we are building analytics systems so that you don't do anything around those gray boxes. We're going to talk about BigQuery, our serverless data warehouse. You move the data in. No need for you to build indexes. No need for you to do disk vacuuming, performance tuning, any kind of patching, updates. Everything is taken care of by Google. You move data in, and you fire queries, and you get your insights. This is fundamentally different than the traditional on-premise MPP-based architectures of analytics. So moving to the cloud is not good enough. You need to reimagine how to architect a solution, and we are making it easy and simple for you with serverless analytics. Customers across the globe, from retail, financial services, logistics, healthcare, are embracing Google Cloud Analytics to build solutions. We are going to hear from TK how they are building financial services application using Smart Analytics platform. Think about HSBC, close to our house here. AirAsia, Gojek, great customers in Southeast Asia. They're building analytics and smart applications on Google Cloud Platform. And we are going to go to some specific examples in the subsequent sections. So we talked about the Smart Analytics platform, the comprehensiveness of it. It's serverless. That means you don't do any system engineering work. You just move your data in and start doing the analysis immediately. So what you can do with the platform, what type of solutions you can build. Of course, you can build vertical solutions, business applications, but I'm going to talk about a few solutions which are horizontal, could be applicable to everyone in this room. You can build a modern data warehouse on Google Cloud Smart Analytics platform that can go from a few gigabytes to petabytes of scale. You can build streaming analytics solution for real-time analytics. You can modernize your Hadoop and Spark-based on-premise systems by moving them to Google Cloud. And we're going to talk about how customers are getting value out of it. And of course, when you do this, we don't want you to create another set of data silos because some of your data systems are running in Google Cloud, some of them are on-premise. So we're going to bridge that gap between on-premise system, Google Cloud, and maybe you have data with other SaaS applications. And then while you do all of this, your data needs to be secure, governed, so that you have complete control and peace of mind. So let's jump right in and talk about modernizing data warehouse with Google Cloud. How many of you here have a data warehouse in your company? Let me ask this question. OK. It's kind of evident, right? Every company has some sort of a centralized repository of data. And all these data warehouse systems are right now massively challenged to handle this astronomical data growth. We are talking to customers day in and day out. Their data warehouse systems are melting. What does Google BigQuery do? Google BigQuery is a fully managed serverless enterprise data warehouse system. We have decoupled storage from compute infrastructure. So you can essentially independently grow your data storage in the BigQuery system. You can run queries on petabytes of data using simple SQL. But BigQuery is not another data warehouse which is very similar to what exists in the market. It's magical. It has inbuilt in-memory BI engine for fast, sub-second, low-latency query performance. It has built-in real-time analytics capability. You can stream in up to 1 million rows per second into the data warehouse without impacting the query performance on the data. It has inbuilt machine learning capability with BigQuery ML. We introduced earlier this year new algorithms where data scientists are able to build ML models using simple SQL. They not need to know Python or R. It's game-changing. So what does that all mean? When you go to BigQuery, you're able to analyze data at scale. You're not doing system engineering. You're able to do new types of analytics. It saves a lot of money for customers. Enterprise Strategy Group ran a study to compare BigQuery total cost of ownership with data warehouse systems that are on-premise, like traditional MPP systems. BigQuery is at least 52% lower than on-premise system. And we asked and interviewed customers who have moved those legacy data warehouse systems to AWS because they wanted to cloudify. They are still paying 41% more than what they would have ended up spending with BigQuery. So just moving, lifting, and shifting the data warehouse to the cloud is not the most efficient option. We keep hearing, are all cloud data warehouses the same? If we just move to a new cloud data warehouse, is it going to give me the cost advantage? Cost is top of mind for all of you. We talk to CIOs. Data warehouse cost is something they want to cut down. Not all data warehouses are same. BigQuery is architected fundamentally in a different way, and that has caused huge cost implication. I'm going to show you a slide. I think this is the first time we are showing this in any summit across the globe. We recently published a report with Enterprise Strategy Group where we compared the TCO of BigQuery with AWS Redshift, Snowflake, and Azure SQL Data Warehouse. And BigQuery is 26 to 34% less expensive than any other cloud data warehouses that are out there. Just take a pause and think. It's game-changing. It's completely new type of architecture that's giving customers this magnificent cost efficiency. And customers are using BigQuery. If you look at the spectrum of some of the larger customers you're using, like think of Spotify or Snapchat, like really large digital native companies, to traditional companies like HSBC, BNP Paribas, Deloitte, 20th Century Fox, like big brands across the globe, small digital native startups, large digital native planet-scale companies across the globe are using BigQuery and getting value. Earlier this year, we announced an offer for our customers. The customers who want to move from on-premise data warehouse systems to BigQuery, Google is offering free training, deployment planning services, and POC credit for customers to help expedite this migration journey. If you have questions, see us at the booth. We'll be helping you to answer these questions, how to apply and get started. So we talked about modernizing the data warehouse and moving to BigQuery. But we don't want you to create data silos because you will not have all your data in the warehouse. If you're using Salesforce, Marketo, Zendesk, you have data in those SaaS applications. If you're using SAP, you have data in SAP HANA. So how do you make sure that we bridge the gap between all those data systems? Earlier this year, we announced a new service called Cloud Data Fusion. It abstracts Dataproc underneath. So it's basically an abstraction layer on top of Dataproc. It's a visual UI-based ETL service that lets you create data pipeline, bring data from hundreds of data sources, including SAP HANA and other applications, seamlessly into BigQuery or Google Cloud Storage. This service is available for you to go ahead and try and play with. We also announced 100-plus BigQuery data transfer services with key SaaS applications such as Marketo, Stripe, Salesforce.com. So if you're using those applications, in a few clicks, without writing a single line of code, you can start moving data from those SaaS applications in BigQuery and then start analyzing the data. And some of our customers, they said, hey, we have data with Teradata. Or we have already started using AWS Redshift. What do? We announced data transfer service to move data from Teradata to BigQuery. These are one-time loads, customers who are trying to migrate off those systems. There are customers who are moving off AWS Redshift and coming to BigQuery because of scale and efficiency issues. And we are making this simple with the data transfer service between Redshift and BigQuery. Let's go and talk about Hadoop and Spark. Don't we love them? Like they were the poster boys of the big data processing paradigm. A lot of our customers have invested in Hadoop and Spark systems, and they're finding it really difficult to manage them in the long term. Google Cloud offers a few options for customers. So if you're running an on-premise system to do distributed computing using Hadoop and Spark, You do pretty much everything on your own, from managing the infrastructure, scaling, dev integration, monitoring, writing the code. You can take those jobs and run it in Google Cloud, in Google Compute Engine, and then Google can take care of the actual hardware infrastructure complexity so that you can focus on writing code, doing integration, scaling on your own. It gives you some flexibility. You can bring the code as is and get started with moving to cloud. But a lot of our customers are saying, can we modernize our Hadoop and Spark deployments and use a completely serverless topology so that I am not worried about scaling issues? I'm not worried about integration. I can just focus on writing MapReduce or writing Spark jobs. This is what Dataproc does. And I keep telling, what does it mean for businesses? When you move to Dataproc, what do you end up saving? You end up saving a lot of money. This is the ESG study that compared data processing jobs running in Dataproc compared to on-premise Hadoop and Spark-based systems. It's 57% less expensive. And then when you are running the same jobs in AWS EMR compared to Dataproc, it's almost 32% less expensive to run those jobs in Cloud Dataproc. So again, the meta point is running Hadoop and Spark in the cloud is not just good enough. We need to think about the technology stack more holistically. Look at the architectural choices, because it has a cost implication that's going to hit your IT budget directly. Any Pandora users here? Listen to podcast or music from Pandora? So Pandora is one of the world's leading music streaming and broadcast companies. And they had an on-premise Hadoop and Spark-based systems with 7+ petabytes of data in their on-premise data lake. But they have 60+ million users who are using Pandora app from 200+ different devices. And they wanted to understand the real-time behavior of those users, which song they're listening to, so that they can serve them personalized content. They can serve them personalized broadcast or music recommendation. So they came to Google Cloud. They moved their data to Google Cloud Storage, the on-premise data lake data, and they're bringing in real-time streaming data from those 60+ million users and moving into BigQuery and doing real-time analytics using simple SQL at a fraction of a cost and effort. Just imagine the complexity of this type of a system. And they're running it in a serverless environment, and they're up and running within like a record time. They're able to do A/B testing much faster. What type of content is resonating with customers? Streaming analytics is becoming real. You know, IDC predicts by 2022, almost a quarter of world's data is going to become real-time in nature. I'm sure you have heard about this term, becoming data-driven. Becoming data-driven is a strategic choice for a company. Which market should I invest in? What type of product should I launch? These are all data-driven decisions. Strategic decisions have long-term business implications. But businesses are trying to be more event-driven. They want to change the price of a product dynamically, depending on how the market is receiving that product or how competition is pricing. This type of analytics systems are fundamentally different from traditional batch-oriented data systems. Companies are increasingly investing in real-time, event-driven architecture so that they can get data from real-time. Like in the example of Pandora, they are getting real-time data from devices, trying to understand the behavior of the users, how they're interacting. We have many customers who are doing real-time website personalization based on clickstream data. Google Cloud offers a serverless streaming and batch processing, unified streaming and batch processing service. So Cloud PubSub allows you to ingest data from any device and system. Cloud Data Flow, you can use Cloud Data Flow, or you can use Spark if you're comfortable using Spark to do real-time or batch processing of the data. And then you can store that data in BigQuery in real time and start querying the data in SQL. And then Reza is going to make that real for us and show the magic, how real-time data can come into a data warehouse, and you can write queries and get that data. That's magical, and this is something that we are seeing. And then customers who are comfortable using open source, Kafka, Spark, they have an option to use those services too. So with that, I want to make it real and call Reza to show the magic of streaming.
Thanks, Sam. Good afternoon, everybody. So for this demo, we're going to make use of a food retailer, which is stores open 24 hours, 7 days a week. The head of sales has asked us to do more targeted couponing based on real-time inventory data, which is going to require us to have access to real-time sales data. Now, for the head of IT, this is a bit of a problem because right now they have two issues. First of all of the point-of-sale data is processed in batch at the end of the day. Secondly, he has a small team. So any new system that we build has to be operationally very efficient. So we're going to rely on some of the technology that Sat was talking about around that serverless analytics and build an architecture that meets those requirements. So first of all, we're going to take that point-of-sale data, and rather than process it in a batch at the end of the day, we're going to send it as it happens to Google Cloud PubSub. We are then going to process that data using Google Cloud Dataflow. We're going to do two things with every piece of information we get. First, we're going to send it to our data warehouse using its streaming capabilities. Second, as we're now doing stream analytics, we're going to connect our data processing systems with our operational systems by sending our inventory folks real-time data. OK, so if we can move over to the laptop, please. Sorry, bear with me. There we go. Okay, thank you very much. So because PubSub is fully serverless, I can't show you a deployment or an install, because all you need to do is create the topic, and we send our point-of-sale system to it. What I can show you is data flowing into the topic. So these graphs are from Stackdriver, which monitors our systems. If I just highlight this one. So right now, our point-of-sale systems is sending around 200 messages a second into Google Cloud PubSub. Obviously, it's a very successful food store. That's a lot of sales over a day. The good news for our sales, for our IT team, is that if this 200 suddenly becomes 2,000, 20,000, or hundreds of thousands, there's nothing extra they need to do. This is a fully managed service that's going to automatically deal with that load. On the right-hand side, we have a different graph, which is actually showing the time every element stays within PubSub. So how quickly are things being processed as we're seeing them? And on average, it's being processed within 1 or 2 seconds. Now, what is the thing that's doing the processing? Google Cloud Dataflow. Now, to show Google Cloud Dataflow, I'm just going to switch tabs. Here, we can see the monitoring interface for Google Cloud Dataflow. The graph you see is a representation of the code that I've written to do the processing and what it looks like in a visual form. At the top, we have PubSub. So we are reading information from our topic. On the right-hand side, I'm just going to expand this. Since this pipeline was started, there was 70 million elements have been processed. In terms of what the data flow is actually doing, so in this middle branch, we're actually sending information to BigQuery using BigQuery's streaming API capabilities. So that data is staying nice and fresh, and we'll come back to that and show that in a moment. But now that we've got a streaming system, how do we connect this directly to our other parts of our business? Well, we can actually do some stream analytics. What I've done here is I'm doing some processing of the data that's coming in. It's coming around 200 messages per second, as you can see. I am doing some aggregations and counting the amount of sales per product per store. Now, if you'll notice at the bottom, I am actually sending this back into PubSub. So PubSub is no longer just being used as a way to ingest information. It's being used as the glue to connect data flow to other parts of our systems. In this case, we connect it to the inventory department. So now our data department is sending up-to-date live information to inventory so they know when they need to send things out to different stores. So here we have the processing being done for data flow with data flow. Let's look at the data warehouse. So I'm now on to BigQuery's user interface. You know, as Sat mentioned, this is fully managed. There is no create database button. There's no create cluster. There's no maintenance button. So again, we're hitting our targets in terms of low operational cost for my IT team. In terms of what we're going to run the query on the left-hand side, if I just expand this, we have the data sets that are available to me. So in particular, the order with lines table is the table that's being having all that information from the point of sale systems sent to it. It's got a schema as you would expect. Under details, if I just go through here, since this table was created, we've put in about 1.7 billion rows of information. Scrolling further down, we can see that the streaming buffer is active. In other words, while I'm speaking, this table is being updated with that point of sale information. Okay, so let's run a little query on this table. Let's just zoom out a little bit. For this query, I'm going to do a couple of things. I'm going to join that table with location table that contains information about the position and city of the stores. On the left-hand side, that table actually belongs to a different data set. So again, SAP talked about this, that we can just load data in and breaking down silos. The facilities department, all they had to do to give me access to that data to join in my SQL statement was to go through the proper security and access controls and grant me permission. There was no import, export, moving of the data around between the departments. And that is helping breaking down the silos. The query I'm going to run, join those two pieces of information, and I have a simple predicate here that is essentially going to look for sales in the last 10 minutes. So we're going to run that. Zoom out a little bit while that's running. So this is completely running against that table, the one that had the billion rows. We have the information being provided. I have, for convenience, placed a column here, which is the current time, 12:24:41. And you'll notice that the last sale in the New York store was at 12:24:38. So within 3 seconds of a sale happening in the store, our data warehouse has the right information. And so, if you recall, in our Stream Analytics, does the inventory department. So with this, we've actually been able to show that we can build the streaming end-to-end pipeline. I will go back to the slides now, please. Thank you. So here, we built a system that takes the point of sale information, processes it through PubSub, works with Dataflow to connect to our inventory department, and lands in our data warehouse. This demo, there's actually an extended version of this at the demo booth outside, where we connect to our CRM system. We also do some machine learning on the data to do the couponing that we had talked about at the start. Okay, so with that, this was a retail demo using this architecture for a different type of industry. I'm going to invite onto our stage TK, who's the Chief Investment Officer for Grasshopper.
Thank
you. Based out of Singapore.
Yeah.
So if you could walk through how you use this architecture for your industry, and also 3 of the key learnings that you had along that journey.
Sure. Do you mind if I grab the
Yes, sure.
clicker?
Sorry.
Thanks. So hello, everyone. My name is TK. I'm the Chief Investment Officer for Grasshopper. Grasshopper is a proprietary trading company that has been providing liquidity to major exchanges around the world, including the one locally here, Singapore Stock Exchange, Japan exchanges like Tokyo Stock Exchange, OSE, and in the US, CME. We consider ourselves to be an innovation-driven company. We have about a team of 70 people, and we've been working with Google Cloud since 2017. At the end of the presentation, I will share with you the 3 biggest takeaways from our journey itself. So here's our problem statement. In trading, it's a very highly competitive field, right? High-frequency trading requires us to constantly evolve and innovate. And we need to innovate fast. So since 2006, Grasshopper has been a trading company that uses technology and pivoted to a technology company that trades. And in 2017, we pivoted again and we evolved into a data-driven company by using GCP. GCP allowed us to innovate on our quantitative research and trading without boundaries. As you can see on the slides, changes in technology constantly affects the way we trade and affects the world of trading itself. CPUs becoming faster, latency decreasing, and creating more data. Storage costs has also decreased, hard drives becoming larger, and allowing us to store more data. I think both Seb and Reza has sort of talked about how a lot of more data has actually affected how we have to spend a lot more time storing this data, figuring out how to query this data, and we've kind of passed this responsibility on to Google Cloud. So what does this mean for Grasshopper? It means that we are able to apply more AI, spend time more on research, and also allow our quantitative studies to study a lot more data, which means we use BigQuery. So just to wrap up, my 3 big points and the big 3 takeaways that I had with the journey, starting from the left side, enabling scale. Just imagine somebody in my research team having to come to talk to me about predicting the infrastructure requirements that they need to do the research, or the storage space they need. But to be truthful to you all, a lot of the researchers' job is to actually explore the unknowns. So if you're exploring the unknowns, you actually do not know how much infrastructure you actually need before you start your project. So if you request for too much, it becomes wasteful. Now, if you request for too little, which is most of the situations we end up with, is that we limit ourselves on the second point, which is cycles of innovation. If you are limited by infrastructure, so is your rate of innovation. So imagine your current rate of innovation is 7 days. And every 7 days, you come out with a new trading model. What if you could actually 10x that, or 100x that, or even better still, you could 1,000x that and reduce that rate of innovation, that period that you take to calculate and do your research, to just 10 minutes. What would that do to your rate of innovation for your company itself? And for the last part, it's something we actually discovered along the journey itself, which is design with abundance. What we focused on was how we could use the cloud to actually design in a different way. For most of us who've kind of developed technology over the last 20 years, we've normally developed technology with limited infrastructure, sort of a test server, or sort of testing or building on your laptop itself. Basically scarcity, but also with cost constraints. What if you could solve these problems with abundance? Meaning you could actually design assuming a lot more hardware than you actually need. Start with something with a lot more compute power, store everything. Some of the questions we asked was, what data do you want to store? Back in the 20 years ago, we had to decide how much data we wanted to store because the disk sizes were very, very tiny. But right now, we could store everything that's coming in from the exchange and then figure out from that what we wanted to keep. I think with that, I appreciate all your time for letting me share my journey with you all, and looking forward to hearing a discussion from this conference later.
Thank you very much, CK. Really appreciate it. And with that, we'll bring Sat back on stage.
Thanks, Reza. Awesome demo. What a great story. Big data analytics is helping customers to innovate faster, operate in an unconstrained environment. What about data protection, security, and governance? This is becoming top of mind in all the data leaders or CIOs in companies. Many of you are here. Google Cloud offers an end-to-end security and governance across the entire data lifecycle. You can encrypt data at rest or in motion. You can mask data on the fly using Cloud DLP, data loss prevention service, manage access control, exfiltration risk. We have access transparency policies. And Google Cloud is always subjected to highest standards of third-party audits for regulatory certification and compliance purposes. And that's why a lot of leading banks, healthcare companies are coming and using our service. We introduced Data Catalog earlier this year. If you haven't played with the service, it's a metadata management and data discovery service. You can tag data, both business and technical metadata, do data discovery and analysis. It's fundamental to our portfolio. But we are not in this journey alone. Many of you have already invested in many other tools, ETL tools such as Informatica, BI tools such as Tableau, Looker, and others. Google Cloud is deeply integrated across data ingestion services, data processing services, BI reporting. So you can bring best of those tools from our partners to Google Cloud and get complete value of your data. You're not throwing away anything. Forrester and Gartner both have recognized Google as a leader in the data analytics space. And if you are interested to learn more, those reports are available for downloads from our website. So with that, I can't be more excited to share these stories with you today. We talked about customers. We talked about examples of innovation. I'm looking forward to see what you do with data and how you use Google Cloud to take your business forward. Thank you very much.